Show that x squared plus 6x plus 11 can be written in the form x plus p all squared plus q, where p and q are integers to be found. So this is saying to complete the square. So I'm going to write down x plus half of the 6, which is 3, all squared. I'm then going to subtract the 3 squared, which is 9. And then I shouldn't forget the plus 11 that I had on the end. I can then simplify that because minus 9 plus 11 is 2. And just to prove that that's the same thing that we started with, I could expand these brackets to get x squared plus 6x plus 9 plus the 2. And so you can see that this is what I started with. So that's correct. So half the 6x to get the 3, take away the 3 squared, and then add the 11. So that's part A done. It then says, in the space of the top of page 7, sketch the curve with the equation y equals x squared plus 11x plus 6x plus 11, showing clearly any intersections with the coordinate axes. So I obviously don't have a page 7 here, so I'll do mine down here, where I've got a little bit of space. So here are my axes. Here's my x-axis, here's my y-axis. Right, I can see that it's going to intersect on the y-axis at plus 11. When x is 0, if I make 0 here and here, I just see that y is equal to 11. So I know it's going to go through the coordinates 0, 11. This is telling me that my turning point of this will be at minus 3 and plus 2. So minus 3 plus 2, that coordinate is roughly here, minus 3, 2. The x coordinate is minus 3, the y coordinate is 2. It's a positive x squared, it's a plus 1 in front of the x squared, so I know it's going to be a U shape. So drawing this quadratic in, it's going to look something like this. So this is the graph of y equals x squared plus 6x plus 11. We can see that this does not intersect with the x-axis at all. It does intersect with the y-axis at 11. So I have shown all of the intersections with the coordinate axes. And the last part of the question says to find the value of the discriminant of x squared plus 6x plus 11. The discriminant, remember, is b squared minus 4ac. In this case, the a is 1, the b is 6, the c is 11. So a is 1, b equals 6, c equals 11. So if we substitute those into the discriminant, we get 6 squared minus 4 times 1 times 11, which is equal to 36 minus 44, which is minus 8, which is obviously less than 0, which makes sense because, as we've just seen from our sketch, the quadratic does not intersect with the x-axis. So it makes sense that the discriminant is negative because we know there's not going to be any roots. There we go.